So today I will discuss the selection of pump, how we can select a pump so it will perform at its best efficiency point. So here you can see two types of pump. One is centrifugal pump and another one is submersible pump, which we use in our underground wells. If you pick a pump randomly, so what will be the effects? It may overpump, wasting energy and increasing wear. It may underpump, insufficient flow or the pressure for the system. It may operate from its best efficiency point, low efficiency, vibration, cavitation and shorter life. So how we should select a pump so that it will perform at its best efficiency point. So see, we have to select this pump by using the curve. You can see at the top there is pump curve. This pump curve is supplied by supplier or manufacturer. But the below curve, you can see this is system curve. So wherever these two curves will be intersect, point of operation will be that point. On the horizontal scale, this is flow, it is in liter per second. In vertical, this is total pressure in Pascal. So pump curve supplied by the supplier and system curve, we have to, as a designer point of view, our system, this curve will be generated from our system. So how we can generate system curve? System curve depends on two factors. One is static head. Static head is vertical distance. In this figure, you can see this discharge head, this vertical elevation from pump to tank vessel. So this one is vertical head. In underground, our pump, submersible pump, in that case, our underground elevation height, that will be the static head. Second one is friction losses. Friction losses are due to pipe friction, fittings, walls, elbow, filters, etc. So all these factors will contribute into friction losses. So when we will find out these two, we will make summation. We will make sum of both. So in pipe pressure losses, we use this equation and we will find pressure losses in pipe by Darcy-Weisbach equation. So you can see this factor, F factor from body chart, and L is pipe length, D is internal diameter, rho is fluid density, V is fluid velocity. And second one, fitting losses. So fitting losses, we have to first of all to find out the K losses. We will find out from tables. Rho is the density, V is the velocity of the pipe. So finally, when we have static pressure head and this minor losses, we will sum all of them. So what are the steps? First step is determine flow rate. How much flow rate we require? It will be in gallon per minute or liter per second. Second one is velocity. If we will divide flow over area, we will get velocity. Third one is Reynolds number. When we will get Reynolds number, we will find this friction factor from the charts. So calculate the friction losses along the pipe length, calculate minor losses. Minor losses are fitting losses and wall losses. So sum them. Then there will be total head loss. Okay. So whenever we have total head loss and total head loss, that head loss will be along with some reference with flow rate. So when flow rate will be more, pressure required is also more for system curve. But for pump at shut off, this is shut off point. So when there is no flow, this pump will generate 150 kilopascal. As flow rate is increasing, see from here to here, flow is almost 13 liter per second. When for pump flow is increasing, pressure will be decreased. So manufacturer always provide pump curve like this, and also he provide best efficiency as percentages. So you can see 45, 55, 60. So best efficiency is lie here 80, 90. So if pump will operate at this point, at this head and total pressure loss, then it will consume minimum energy. So in the last I will tell you there are two different kind of curve. One is steep curve, one is flat curve. These curves are from supplier. Okay, steep curve used for open system like our cooling towers. Okay, and flat curve for closed system using two-way valves. So chilled water, when we have closed loop, then we have to use this flat curve. So now I will go toward one example. You can see this one is Comex brand curves. So see, supplier provide us curve in feet and flow rate. In the horizontal flow rate, and here is feet, here is head. At the bottom, see, he provided one more curve with reference with efficiency and kilowatt. So this red curve is its efficiency, and this blue color curve, this is the power consumed in kilowatt, and this black one is our system curve. So at this point you can see it will consume minimum power, you can say optimum power, and efficiency is also highest at this point. But if our system curve is like this, so here you can see efficiency is more, efficiency is almost like 68%. So if our system is like this, so we can choose this one. So whenever we have to buy a pump, we have to see all these factors, and then if we will select the pump will be performed at its best efficiency and using less power. And in below table you can see here is GPM, and these are the heads. So from head and GPM, and as per best efficiency point, we have to select our desired pump from this list. Hopefully you get the idea of selecting pump from its curve. Thank you very much.